This is the second page of the AP spring or for the non-AP spring review. So let's look at number 6. Find the equation of the tangent line. So to find the tangent line equation, we first need to find the derivative function, and then from the derivative function we can find the slope, and then from the slope we can gather that into a point slope form. So the rule for e to the u is e to the u times u prime. The 2 stays, that's 2, that 2 is just a coefficient. So the derivative for 10 minus x squared, 10 goes to 0, negative x squared becomes negative 2x. So there's my slope formula. I'm going to push that negative 2x, might make it multiply with the 2 in front. So negative 4x e to the 10 minus x squared. There's my slope formula. If I give it an x value, I can get this, find a specific slope for this specific point. Plug 3 in for the x. We get negative 12 e to the 10 minus 9, which is raised to an exponent of 1. 10 minus 9 is 1. And this becomes negative 12e. This looks like something that we can clean up a little further, but that's just our numeric answer for our slope. E is around 2.7, so maybe this slope is around 24, 25-ish. But we'll leave it in exact form, so that's just a numeric value. That's our slope. We have our order pair, which is 3 and 2e. So we have our x and y value, we have our slope, and now we just put it into point slope form. Okay, number 7. We're moving into definite integrals. This is a second semester further topic here. So we can expand this term. We can bring the x to the 4th up to the top and just rely on power rule to do our rest. Well, after we expand. So we need to expand a little bit more. We can distribute this through. When we distribute and multiply bases, we're going to be adding exponents. So negative 4 plus 1/2 is the same thing as negative 8 over 2 plus 1/2, which is negative 7 over 2. Negative 4 plus 3 is negative 1. So now that we have 2 separate terms, no more parentheses getting in the way, we can apply power rule. So power rule, we add 1 to the exponent, so we do plus 2 over 2. Which becomes negative 5/2. And we have a special rule for 1 over x. The rule for 1 over x is integral of 1 over u du is natural log absolute value of u plus c. So we just apply that rule. This is the one rule that power rule is not able to manage. So we go through minus 7 natural log of absolute value of x plus c. Okay. Now back to this. I don't think I finished this here. If I added 2 over 2 as adding 1 to my exponent, my numerator is going to be x to the negative 5/2, but divided by negative 5/2. If I multiply this negative 5/2, flip it up as negative 2/5, I'm going to get negative 2 because the 5's cancel out. And there's my indefinite integral. Okay, number 8. Tangent of 5x minus cosecant of 3x, both of these require u substitution. Our u value can be easily found by looking at what's inside the parentheses. Our u value is 5x, derivative is 5, dx is du over 5. We're going to get a coefficient of 1/5 that's going to tag along to the antiderivative of tangent. And then for cosecant, our u value is 3x. We find our derivative. We have du over 3. Right? We push those coefficients out in front, and we have specific rules for tangent of u and for cosecant of u. For tangent of u is negative natural log of cosine of u plus c. For cosecant, our rule is negative natural log of absolute value of cosecant u plus cotangent u. We place the u back in terms of x, and we have our answer. Okay, number 9. This is going to be a u substitution problem. We can push rewrite this as a rational exponent. We can push that radical up to the top. So our u value is looking at us directly when we can see it directly inside those parentheses there. Our u value is 6 minus 4x to the 4th power. We find the derivative, du over dx equals negative 16x cubed. We cross multiply, we get dx negative 16x cubed equals du. We divide both sides by negative 16x cubed, and we get dx equals du over negative 16x cubed. And then we make our substitutions. Okay. Our u value gets replaced, our parentheses gets replaced with u. Our dx gets replaced with du over negative 16x cubed. The x cubed cancels out nicely for us. We want to push out any coefficient that doesn't display as part of the variable. So we can push that 4 over negative 16, which reduced to be negative 1/4. And now we have a nice clean power rule to apply. Okay. So power rule, we add 1 to the exponent, so plus 3 over 3. So negative 4/3 plus 3 over 3 becomes negative 1/3. Whatever exponent we have created up here, we're going to copy that value below. And then we're going to clean up this complex fraction, flip that negative 1/3 up as negative 3. Negative 3 times negative 1/4 becomes 3/4. Our u value still has a negative exponent, so here's our answer. We're going to push this back down to the denominator and replace the u back in terms of our original variable, the parentheses, the 6 minus 4x to the 4th, and don't forget the plus c. All right, so number 10. Diagram shows the shaded region. We have y equals x cubed minus 3, that's the curve here. Y equals 24, that's the horizontal line there. And we have x equals 0, which is the y-axis. So we have the shaded region. We want to find the volume of the solid created by revolving the shaded region around axis revolution of y equals negative 5. So here's our axis revolution. When we want, we know that we see there's an obvious gap between the dotted line and the shaded region. So when this rotates, there's going to be a hole that's created. So we have to draw two radius. One radius that's going to extend from the axis of revolution all the way to the furthest boundary of our shaded region, all the way to this 24 line. And that's big R. And then little r, it's going to be the shorter one. That's going to extend from the axis to the closer of the two boundaries. That's the curve. That's r of x. All right, so we know this is going to be a washer method because we have to subtract out that gap, that hole. So also we need to find the intersection. That's something else that we need because our bounds is going to be from 0 to whatever that furthest right endpoint is going to be. And that right endpoint is going to be the intersection of this y equals 24 and the y equals x cubed minus 3. So we set them equal to each other. Okay. So I can add 3 to both sides, take the cube root, I get x equals 3. So now moving on to big radius. Big R is going to be top minus bottom. So if we look at the top of the radius, it's touching that 24, and then the bottom of the radius is sitting at that y equals negative 5. So 24 minus negative 5, 24 minus negative 5, 29. That's the length of big R. Little r is going to be top minus bottom. The top of my little radius is sitting on the curve on the x cubed minus 3. The bottom of the little radius is sitting at the negative 5. So it's going to be x cubed minus 3 minus a negative 5. Two negatives become positive. We get negative 3 plus 5, which is positive 2. So now our formula for washer method is pi big radius squared minus little radius squared. Our bound is from 0 to 3. We make the calculator do the rest of the work for us. And don't forget the pi with our answer. After everything is said and done, this is going to be a three-dimensional object. So our units of measure, it's units cubed.